Welcome back, cherished viewers. It's like my camera is picking it back. Let me come. Okay, thank you very much. I'm well set now. Okay. Well, welcome back, cherished listeners and viewers. As stated earlier, this Epo-Xi Edition, one of Epo-Xi, we are very sorry for the hiatus in the delivery. It's a challenge far beyond our control. We know the current network issues in Ghana, so the network went off and we had nothing to do but to pause and continue as we've just done. A follow-up to what I said earlier, I said that under Epo-Xi is an initiative of the management of Epi-Xi engineering, and under this we'll be considering academic and industrial discussions on hydrogeology, under which we consider the business of water borehole drilling, consider discussions in geotechnical engineering, geomatics engineering, and entrepreneurship in general. If you want to, you have any concern, any question, anything you want to add, anything you don't understand, you want to consult us, you want to contact us for our services, you can see the flyer for the contacts. But if you want to contact me personally, you can use my email eawimbi@gmail.com. Can contact me on eawimbi@gmail.com or 054-5852-888. I'll be responding to calls and I'll be replying to comments on Epo-Xi from Monday to Friday after 12 noon till 5 p.m. in the evening. Please don't call me midnight making inquiries or trying to get answers to your question. In fact, I won't be pleasant with that, and as such, maybe I will need attend to it. So any time from within the stipulated duration, I'm always available and I will attend to you. Even if I'm in the field when I return, I'll make sure that I will attend to you within that stipulated time. Please, let's be mindful of our language on this program. Let's know that this is purely an industrial and academic session. As such, we wouldn't entertain political comments, neither would we entertain tribalistic and hateful comments. So any comment should be within the scope of our discussion. If you make a political comment here or make inquiries political, we are sorry, we wouldn't be able to attend to you. A tribalistic one, a hateful one, we are sorry, we wouldn't be able to attend to you. Aside that, anything relevant to our discussion, we are always available to attend to you. In fact, Epo-Xi is free. Epo-Xi is free for everybody. We are expecting students, practicing engineers, and those who are interested in drilling a water borehole or those who want to start a water borehole drilling business. You will have to take this golden opportunity and advance your knowledge before you start, so that you don't commit some mistakes. Must let you know that for our industry, any mistake you make is going to cost you thousands of cedis. If you are not willing to lose that, then it means that you have to take Epo-Xi very, very serious. Okay, let's move on straight to this topic of discussion. Okay, so for today, we want to consider volumetric measurements when drilling a water borehole. And particularly for today's session, I'll be considering the unconfined aquifer terrain. So we want to see the volumetrics. What do I measure when I'm drilling a water borehole in an unconfined aquifer? And for Epo-Xi, for the live sessions, we will leave the mathematics aside. For those ones, will be doing the tutorials and uploading them on our YouTube channel. So you can just subscribe to our Facebook page and also on our YouTube channel, and you watch the tutorials for free. Watch the tutorials for free. If you have any question, you can just comment below the video, and when I'm available, or if any of our engineers are available, they are going to respond to you. Okay, so we are going to consider the ideal situation, and we will also take some real life examples. We'll take some real life instances. Now, let's assume that this our surface, this is the earth surface where we are going to drill. So, if you are going to drill, let's say at house A, you are going to drill at this point. What do you measure? We are focusing on drilling. As you drill, what goes into it? Materially, what goes into it? That's what we are going to consider. Today's discussion will be based on the construction aspects. If I'm constructing it, what goes into it? So let's see. Let's say I'm using a drag bait with diameter 8 inches. So means that from the top to the bottom, I'm expecting to get a diameter of 8 inches. I'm expecting a diameter of 8 inches. So this is my 8 inches diameter from the top to the bottom. If we are talking about unconfined aquifer, what you should know is that there is no rock during the drilling. You will not encounter any rock. So from the top to the bottom, it's only loose material that you are going to encounter. So if I'm drilling at point A, and from the top to the bottom, there's no rock to be encountered, then I know that I'm drilling in what? In an unconfined terrain. Then let's see what some of the things I will encounter in there. So from the top to the bottom, let's say 30 meters, no rock encountered, then encounter any rock. So I'm expecting that from the top to the bottom, the diameter should have been 8 meters. Sorry, 8 inches. But that would that be the case? We'll find out. So it means that my depth, let's say 30 meters, we drilled at a depth of 30 meters. So after a 30-meter depth, after drilling for 30 meters, no rock, I'm going to construct that. And by the grace of God, I've been able to encounter economic quantity of water. Then the question like, what will I do? What material will I use to construct it? You need to know that for unconfined aquifers, the depth you drill to, you have to construct from top to bottom. So you cannot construct, you cannot open hole a borehole in unconfined terrain. If you do that, it's going to cave in. Once you do that, it's going to cave in. So from the top to the bottom, the 30 meters, I've drilled that. So I'm expecting that the diameter should be 8 inches. This diameter, I'm expecting it to be 8 inches from the top to the bottom. Then I also bear in mind that I'm going to use at least 31 meter length of casing to complete this, out of which at least 10 meters should be plain screened, or should be screened casing. So it stands to reason that from top to bottom. I'm going to casing that. So this is my casing. Out of this, 10 should be slotted. In order for water to enter to the bowl. After you have your slotted, your what do they call it? Your casing installed, then it means that you need gravel. You also put in what? Gravel. So the gravel should cover up to a maximum of 27 meters. A maximum of 27 meters. So let's say this is my 27 meters. This is my 27 meters. So this whole place is going to be gravel. This whole place is going to be gravel park. I'm going to gravel park that. And after you've installed your gravel park, what comes next is the ground seal. The ground seal. You can use concrete. You can use concrete for your ground seal. And under special occasions, use bentonite. But for domestic goals, we usually use concrete. If the client can afford, you can also use what? Concrete. So, because it is unconfined, your ground steel should extend from this point to almost the surface. If not even the surface, it should be almost the surface. This stands to reason that your ground steel should not be anywhere less than 2.5 meters. The reason being that any part of the surface or anywhere there is contamination, there is a possibility that it can enter your borehole. As such, you should construct it in such a manner that water cannot, what the contamination from surface water will be minimized. Because it's unconfined and the water is also coming from all angles. As such, you should minimize what? Contamination by making your ground seal very thick. So, this is my ground seal. That is very thick. This is my ground seal, very thick ground seal. Then you can now do the completion. When you drill in an unconfined aquifer, be very careful not to put in backfill. Be very careful not to put in backfill. So after your ground seal, there should be another concrete finishing on the surface, so that water does not find its way to accumulate on top of the ground seal. One thing is that the ground seal might not hold your screen firmly. As such, if water accumulates here, it will be seeping bit by bit and also through the walls into your borehole. As such, you should have another thick layer of concrete on the surface as a finishing in order to protect it also from surface runoff. So you've done that. Remember, I said from the onset that you need 31 meters casing, 31 meter casing. The reason being that after this whole thing, your casing should extend beyond the surface of the ground, such that surface water will not be able to, enter or stagnate on top of your borehole easily. So we protrude that, so it's a bit above the surface of the ground or the earth. That's the one over there. Then you can now do your completion. Today I'm not going to consider the mechanization aspect. I'm considering the construction aspect alone. Now, realize that with this we have D1 here. There's a reason. There's a reason why I'm saying D1. Then we have small d1. This is not appropriate. Small d1 here. So it's assumed that with this d1, I can easily calculate the volume of gravel I'm going to use. For 30 meters, we usually use not less than 30 bags of gravel. So you should be estimating around 35-40 bags of gravel. But the 30 bags you are estimating, you may use less or more than that. Why is it so? Reason being that the earth is not like a prototype we have in the laboratory. See, when we are calculating like this, because it's on a rigid material, you have your diagram intact, nothing changes. But when you are drilling, that's not what you encounter. When we drill, what happens is that this hole you've created, because it's within loose material, one thing you should be cautious about is caving. The walls can easily cave in. As such, the quantity of gravel pack or gravel that should have been used for the gravel pack can change. You can use more. When you are drilling in an area like Obuasi or Wasankonya, the Wasa areas, you should know that your budget for gravel should be higher. Because the formation over there, it caves in a lot. And I will have time and discuss that one on one of our lectures. There are some special sites that they need special treatment. So in those areas, you should know that this particular wall is no longer going to be like this, but it's going to be something like this. The reason being that, so at the end of the day, your casing is going to be here. You have the slottings. And this whole area will be gravel. Also stands to reason that your ground seal, a lot will also go in there. So you have your ground seal here. Any other thing is the same. Any other thing is similar. So you have this. Comparing this to that means that the amount of gravel you use be very huge. In a similar manner, the cost is going to be equally huge. As such, if you are charging for a project, you have to consider both the positive and the negative. Don't go and charge based on the ideal situation, and at the end you run and leave the project, or you be in court defending yourself, defending what you cannot even defend. If you are a client watching, I want you to understand that there's a lot which goes into drilling. As such, you have to drill, you have to bear with the engineer on site. You don't influence the engineer to do something against standard practices, and at the end of the day blame him or her again. So this is one of the scenarios. So under this, due to caving, you may use more gravel than required. Let's also consider the second scenario. In the event that you may also use less gravel. Let me finish with that one and give us the advantages and disadvantages. This one, you use more gravel. On at places like Adujama, Mankranso and Go, you are going to use less gravel, and this is why. Say this is your hole. For the first 10 meters is going to be consistent. For the first 10 meters, It's going to be consistent. After 10 minutes test, it starts bulging. And by the time you get to 30, you have something like this. So it means that this is your casing, it goes in there. Goes in there, have the ground seal. Have the ground seal over here. Okay. And the final finishing on the top. Okay. So you realize that with this one you use less than the ideal case. And with this particular model, you use more than the ideal case. Both of them have their advantages and disadvantages. But for this one, if you are drilling at Parakou Estate in Kumasi and this environs, know that you encounter something like this, or you drill around Krono and those places, you have the ideal case. This has advantages and disadvantages. This one has and that one has. We will consider those ones and call it a day if God permits. When we meet next week, we are going to consider an advanced form or another scenario under this, and afterwards I'll upload the tutorials so that when you encounter something like this, you know what to do on site, or if you are in such areas, you know what to do, or you know what the one to contact to drill your borehole for you. Now, let me start from here. With this one, you are going to use a lot of gravel. Use a lot of gravel. But at the end of the day, you are going to get a lot of water. Your water is going to be very clear. The reason being that the screen or the slotted portion of the casing pipe is highly immersed in the gravel pipe. So the water incoming is sieved through a lot of screens within the gravel pipe before it gets to the borehole column. That can hardly be said about this. With this one, as you drill deeper, the clay swells. As you drill deeper, you encounter more clay, and as you encounter it, water will be gushing in from different parts of the walls, and it will be causing the clay to swell. As it swells, what happens? Means that it's going to affect your casing. That's one. And if you are not very fast, by the time you finish drilling, it are closing, and you have to apply a lot of effort in order to drive your casing through. That is the case. It means that most parts of your screen is going to be in contact with the walls of the borehole directly, rather than the gravel. So if that so happens, what will happen is that your water will get clear within minutes, and as you pump it with time, it muddies again. So this is the reason why most boreholes are like that. So if it so happens, it's not always because the contractor or the engineer didn't use the best practice, but sometimes it's due to some of these reasons. This is happening deep within the earth, and it's very difficult for the engineer to control. So with this particular one, the remedy, or one of the things you can do as an engineer, is that if you are drilling here and you know that this is the situation on ground, you should be very fast. Don't delay for anything. have all your material intact before you start drilling. So immediately you are done, the casing goes in, you gravel pack before you do any other thing. But if you wait to wash the borehole before you do any other thing, by the time you realize the clay portion has swollen, and you may not even get the whole 30-meter depth. You may not get the whole 30-meter depth. So anytime you are drilling around areas, you know, as you go deeper, you encounter more clay before you hit the bedrock. Should be very fast. Get all your material on site before you start, and immediately you finish, install your casing and your gravel pack first before you even think about washing your borehole. In doing that, you minimize or to understand, you maintain the diameter of your borehole to understand. You maintain it to understand. But immediately you delay, it's going to swell and you will not get the whole depth. Mind you, your screen is also going to lie within the mud. It's going to worry your client, and your client will also worry you. If you are the client too, you have to know that once that happens, it's going to worry you because you never get the clear water you desire. On this part too, another remedy is that if you are drilling in an area you are already aware that this is what is happening, I would advise that at 20 meters you need to install a casing before you progress. At 20 meters you should install a casing before you progress. So what means is that from here onwards, instead of the 8 inches diameter, your drag bit, you are going to reduce the diameter to, let's say, 7 or 7.5. So what happens is that instead of this whole big diameter, you get a smaller portion which will cave in and comes back to the standard one. And you'll be able to reduce caving within these sites. Or as you drill deeper, it's going to cave in. But if you install the casing, you hold that portion for some time. And another thing is that if you are drilling here, immediately you are done. Install your casing and your gravel pack. At least your casing is the first thing you should do. Immediately you are done, remove all your rods very fast and install your casing. Don't delay. If you delay, you know that, oh, I drilled 30 meters, but I don't really check and this, let's say 50 meters. You might even be surprised, or if west comes to west, you might lose all your drilling rods and your bits because you can get stuck. So if you are drilling around Wasa area, drilling around Obuasi, you should be mindful of this. Be very careful what you do about it. So these are the volumetrics I wanted us to consider today. That with a gravel in particular, in unconfined areas, for 30 meters should have been 30 bags. West comes to west, should have been 40 bags. But due to these two scenarios, you can spend on 70 bags. Yeah, I've ever spent on 70 bags. I think at Wasam Konya, yes, I used 70 bags on 30 meters. There was a lot of water too. In Kumasi, I think we used about 28 bags. We were okay. Pechi, we used about 30 bags. We were okay. Went to Ejama, we used less than that, but this thing also affected us. We needed bend in order to push the casing through. So that's why I'm saying that if you are drilling, you should be mindful of these two scenarios. They might seem very simple, but when you encounter them, it will be very complicated. Be very hot on site. And since I've already passed through that, I wouldn't like you to go through that. There are a lot of mathematics with regards to this. I'll put them on the YouTube channel. I'll upload this particular one there, and I'll be uploading the others over there. So make time and learn on this stuff. If you want to go into water bore drilling, you are already into it. Cannot pay for expert consultancy. This free one for you. So just make time. We know getting data is very expensive nowadays, and that's why we try to shorten things. So once you come online, don't go and be watching some unnecessary stuff. Everything is necessary, but depending on the one it is being applied to. If you are a contractor like myself, you should be studying this stuff at your leisure, not to be watching anything at all. When you are done with this, then you can now go to do stuff. But if you don't know these things and you use your time to watch any other thing, you should know that at the end of the day you are going to struggle. If you get to side, those videos will not help you. Whatever funny stuff they will not help you. Yeah, I do enjoy funny videos a lot. Do watch them a lot, but I will not use the time I should use to study this to do that. When I come online, I watch side videos a lot. I learn side stuff a lot. Also, by advising to do this. Or if you bypass this video and contact us directly, know that that will be consultancy. We are going to charge you. I want to charge you. So just leverage on Epo-Xi and learn this stuff. Also advise students, particularly geological engineering students, civil engineering students, that you should take advantage of this stuff. Usually we say that, oh, I went to school and in the classroom they didn't teach me this. They cannot teach everything in the classroom. Cannot teach everything in the classroom. Some of these things are learned in the field. Most of them are secrets that nobody will tell you. But we are taking it upon ourselves to bring it to you at no cost. So take advantage of this, and we know that it's going to be very helpful to a lot of people. It's going to be very helpful to a lot of people. If you have any question, have anything you don't understand, just comment. Just comment. I've given my contact out, my email out, but I wouldn't like to be answering a lot of calls. No. And that's why I also spoke about the midnight calls. You can call at midnight and bring a contract. Yeah, if you want us to drill a borehole for you, we are always available. But if it's about, I encountered this on site. Sometimes people call at midnight and say, I went to drill here and this is a problem I'm encountering. How can you help me? Engineer, midnight and you are drilling at midnight. I'm fast asleep. That, oh, I've forgotten that it's night at your area. How come we are all in Ghana? So how come that it's night at my area and it's not night at your area? To avoid such circumstances, take such lectures very serious. If God permits, next week we are going to progress on this. We are going to progress on another scenario, and as we build on it, be able to understand a lot of stuff, and it's my expectation that also bring in inputs, we learn from each other and make the water borehole drilling industry of Ghana better. Thank you very much for your time. Once again, I'm Emmanuel Awumbe Atangnaba, Principal Geotechnical Engineer in the Drilling and Geotechnical Engineering Division. Thank you for your time. See you next week.